Two 5-gram point charges on 1 meter long thread repel each other after being charged to plus 100 nanocoulombs. What is the angle theta? You can assume that theta is a small angle. So first you want to draw out this diagram and list out your knowns and your unknowns. So length equals 1 meter, mass is 5 grams, charge is 100 nanocoulombs, and you're solving for tension and ultimately theta. So using what you know from adding up all the forces, you're going to write out the net force, which is tension plus force of gravity plus force of the electron, which equals to 0, because mass times acceleration is 0 since it's not moving. Forces in the x direction will equal to T tension in the x direction plus force of gravity in the x direction plus force of the electron in the x direction, and that will also equal 0. Forces in the y direction will equal to tension in the y direction plus force of gravity in the y direction plus force of the electron in the y direction, which equals to 0. So tension in the x direction is T sine theta, and this is found using trigonometry, minus force of the electron, which equals to 0. And you can rearrange the variables to solve for T sine theta, which equals to force of the electron, and using the equation kq squared over d squared, you can substitute for force of the electron. In the y direction, you have T cosine of theta minus force of gravity, which equals 0. And you can rearrange that and solve for T cosine of theta, which equals to mass times gravity, since force of gravity is mass times gravity. Then using trigonometry, again, you're going to do sine of theta equals to opposite over hypotenuse, so d over 2 divided by the length right here, and d will equal to 2L sine theta. So using these two equations here, you're going to set them as a ratio and T cosine of theta, which equals to mg, and these t's can cancel out, and sine over cosine is sine squared theta tan theta equals to this equation over this equation, which is kq squared over 4L squared mg. That's simplified. And you're going to solve for theta here. So you're going to substitute 9 times 10 to the 9th newtons times meter squared per coulomb squared for K, and the charge is 100 nanocoulombs squared, all over 4 times length, which is 1 meter squared, times 5 grams, which is the mass, and gravity, velocity is 9.8 meters per second squared. Then you're going to multiply by conversion factors. 1 coulomb is 10 to the 9 nanocoulombs squared times 1,000 grams is in 1 kilogram. This will equal to sine squared of theta times tan of theta equals 4.9 times 10 to the negative 4. For small angles, you can use the assumption that tan theta is approximately equal to sine theta. So sine squared of theta, and you're going to substitute tan theta for sine theta, equals to 4.9 times 10 to the negative 4th sine to the 3rd power of theta equals 4.9 times 10 to the negative 4th. Sine theta is 0.07714. You take the cube root of this number, and you will end up with theta equals 4.4 degrees.